Weighing up trade-offs between food security and climate mitigation. IIASA researchers collaborated with colleagues in Japan to clarify the impacts of stringent climate mitigation policies on food security. The team identified smart and inclusive climate policy designs where the risk of food security for hundreds of millions of people could be addressed at a modest cost. In a study published today in Nature Sustainability, an international research group that included researchers from IIASA, Kyoto University, Ritsumeikan University, and the National Institute for Environmental Studies (NICE), Japan, for the first time estimated how food security could be negatively affected by the climate mitigation policies implemented by multi-integrated assessment models (IMS) and the cost associated with avoiding adverse side effects. More specifically, they clarified the relationship between food security and climate mitigation, and provided cost estimates for possible solutions to the trade-off between food security and climate mitigation, taking into account the uncertainty represented by an ensemble of IMS. Food security is one of the areas addressed by the UN Sustainable Development Goals (SDGs). The aim of 2 Sudanese pounds in particular, is to achieve zero hunger by 2030. The issue of food security has been studied extensively in the context of climate change impacts associated with yield changes over the last few decades, and more recent studies also explored the effect of climate change mitigation on agricultural markets. The Paris Agreement defines a long-term temperature goal for international climate policy, holding the increase in the global average temperature to well below 2 degrees Celsius above pre-industrial levels and pursuing efforts to limit the temperature increase to 1.5 degrees Celsius. Accordingly, studies investigating the climate change mitigation required by the Paris objectives have identified a potential need for land-based measures like afforestation and large-scale bioenergy production, which could in turn raise concerns about implications for food security. These low-emission scenarios are making the connection between 2 Sudanese pounds, hunger, and 13 Sudanese pounds, which specifically concerns climate action, increasingly crucial. According to the researchers, climate change mitigation exclusively aimed at attaining climate goals could generate a risk of negatively impacting food security. If not managed properly, the risk of hunger due to mitigation policies is remarkably amplified. Under the 2 degrees Celsius and 1.5 degrees Celsius scenarios, for instance, the risk of hunger drastically changes compared to the baseline scenarios. Depending on the scenario, the results indicate that an additional 130 to 280 million people could be at risk of hunger in 2050. The team further examined the costs of possible solutions to such unintended adverse side effects through smart and inclusive climate policies. Several economic alternatives were explored, including agricultural subsidies, food aid to low-income countries, and food aid only to populations at risk of hunger. The costs of the alternatives were found to be between 0 and 0.46% of GDP. These are very modest figures if compared to the costs of climate change mitigation. The researchers note that direct impacts of climate change on yields were not assessed and that the direct benefits from mitigation in terms of avoided yield losses could be significant, thus further lessening the above costs. While results vary across models and model implementations, the qualitative implications are robust and call for a careful design of climate mitigation policies taking into account agriculture and land prices. While we found a similar effect in an earlier joint paper published in Environmental Research Letters, this time we applied multiple alternative models and showed that the results are robust and have a very high confidence, explains Shinichiro Fujimori from Kyoto University, lead author of the paper and a guest researcher in the IIASA Energy Program. We would like to emphasize that land and food-related climate change mitigation policies should be carefully designed. Policymakers should be aware that potential issues could arise as a result of the uniqueness of the food system compared to, for example, the energy system. The findings of the paper are central to understanding that we can reach very low climate targets together with sustainable land use and agricultural development, adds IIASA Energy Program Director Kiwan Riahi. Climate policies need to go beyond carbon pricing, take into account distributional effects, and shield the poor. If properly managed, the costs of such policies will be relatively small. Trade could be key to balancing conservation of freshwater sources and food security. An IIASA study published in the journal Nature Sustainability Today evaluated whether water for the environment could be prioritized under growing competition from other sectors. The results indicate that this could be achieved by shifting crop production from water-scarce to water-abundant regions and tripling international food trade. Globally, the call to conserve or restore the ecological health and functioning of rivers and their associated wetlands for both human use and biodiversity is gaining traction, and in many countries, efforts in this regard are already being supported by national and regional policies and legislation. To successfully implement these conservation efforts, methods have been developed to define environmental flows, in other words, the quantity, timing, and quality of water flows required to sustain freshwater and estuarine ecosystems, as well as the human livelihoods and well-being that depend on them. Global freshwater resources are however increasingly under pressure, with about 70% of water abstracted from freshwater ecosystems being used for the irrigation of agricultural crops. Around 40% of our food is in fact produced on irrigated lands, while the demand for water from industry, energy, and municipalities is also set to increase in the future. According to the researchers, previous global assessments of the food-water environment nexus did not adequately take into account the water necessary to sustain the health of freshwater ecosystems. In some instances, the dimension of water for the environment was not considered at all. The team wanted to understand the impact that strong protection and enforcement of environmental flow requirements would have on food security, and to what extent the trade of crop and livestock products between countries would be able to buffer the impacts of enforcing these requirements. Irrigation is often considered a silver bullet for achieving food security because irrigated croplands are often more productive than rain-fed croplands due to the fact that they allow farmers to produce crops in areas and during months when rainfall is inadequate. We wanted to see if water for the environment could be prioritized even under growing competition from other sectors, explains Amanda Palazzo, a researcher with the IIASA Ecosystems Services and Management Program and one of the authors of the study. The study examined how changes in the water available for irrigation impacted cropland use and expansion employing the IIASA Global Biosphere Management Model (GLOBIOM) for the analysis. Palazzo says that in the analysis, changes in rainfall due to climate change, growing competition for water from industry and households, and protections for environmental flows were considered as critical challenges for irrigated agriculture to meet the growing future demand for agricultural products. The time scale was also considered significant from both an environmental flow and a crop production perspective. When the monthly demands from municipal and industrial users were considered, the team were surprised by how little water was actually available for irrigation or the environment in regions that may appear to be water abundant at a regional and annual level. The findings indicate that an increase in land use by 100 MHA would be required to double food production by 2050 in order to meet the projected food demand of the world's growing population. There will also be a need to reallocate food production in water-abundant regions and reduce water-intensive crops in dry areas. Trade policies may have an important role to play to adapt to climate change, as an additional 10 to 20% trade flow from water-abundant regions to water-scarce regions will be needed to sustain environmental flow requirements on a global scale. In addition, the findings show that retiring irrigated cropland or shifting back to rain-fed cropland may be necessary to protect environmental flow requirements and meet the growing demands from other users. Sustaining environmental flow requirements would only increase trade by 15%, while decreasing irrigated areas by 20 to 30%, says study lead author Amandine Pastor, an IIASA alumna who is currently associated with the Institute of Research for Development in France and the University of Lisbon in Portugal. In this regard, sustainable and innovative practices such as growing crops within appropriate agroclimatic zones, e.g., planting less water-intensive crops in dry areas, developing urban and vertical agriculture, and limiting the share of meat in human diets, should be adopted. She however cautions that care should be taken with the reallocation of resources so that some regions do not deplete others. The study shows how important it is to realize that natural resources are limited. The results indicate that it could be possible to maintain both food security and environmental flow requirements by 2050, despite the growing population and the rising impacts of climate change. Environmental regulations on water abstractions, sustainable food production, and deforestation are fundamental to avoiding local environmental degradation, and water resources should be carefully managed between human needs and ecosystem requirements to ensure a sustainable future for humanity, says Pastor. Policies or targets that aim to provide adequate food and water needs for a growing population may be at odds with policies to protect the environment. Understanding how the trade-offs for sustainability and development goals play out at local context is therefore extremely important, concludes Palazzo. New research shows community forest management reduces both deforestation and poverty, giving local communities in Nepal the opportunity to manage their forests has simultaneously reduced deforestation and poverty in the region, new research has shown. In the largest study of its kind, an international team of experts led by the University of Manchester has found that community forest management led to a 37% relative reduction in deforestation and a 4.3% relative reduction in poverty. This is particularly significant in a low-income country, where more than a third of the country's forests are managed by a quarter of the country's population. The findings, published in Nature Sustainability, is the largest study on community-based forest management. It estimates the impacts of more than 18,000 community forest initiatives across Nepal, where community forest management has actively been promoted for several decades. Forests are critical to sustainable development. They regulate the world's climate, sequester carbon from the atmosphere, harbor biodiversity, and contribute to the local livelihoods of millions of people worldwide. Over the past 4 decades, governments and international organizations have actively promoted community-based forest initiatives as a way to merge natural resource conservation with human development. Local communities now legally manage approximately 13% of the world's forests. But evidence of the impact of community-based forest management has been largely limited to small-scale evaluations, or narrowly focused studies until now. Lead author Dr. Johan Oldekop, the University of Manchester said, "Our study demonstrates that community forest management has achieved a clear win-win for people and the environment across an entire country." Nepal proves that with secure rights to land, local communities can conserve resources and prevent environmental degradation. Reductions in deforestation did not occur at a cost to local well-being. The study found that areas with community forest management were 51% more likely to witness simultaneous reductions in deforestation and poverty. Co-author Professor Mark Whittingham, Newcastle University said, "It's not easy to balance sustainable management of the environment against the needs, or wants, of mankind." These findings highlight one positive solution. The research, authored by an interdisciplinary team of ecologists, economists and political scientists, overcomes previous data limitations by using rigorous techniques to analyze publicly available data on forests, people, and institutions. The team combined satellite image-based estimates of deforestation with data from Nepal's national census of 1.36 million households, and information on more than 18,000 community forests. Co-author Professor Arun Agrawal, the University of Michigan said, "Identifying a mechanism, community forestry, that can credibly reduce carbon emissions at the same time as improving well-being of the poor is an important step forward in global efforts to combat climate change and protect the vulnerable." Mexico, Madagascar, and Tanzania have similar community forest management programs, with Indonesia and others developing them. Co-author Catherine Sims, Amherst College, said, "We sought to learn from Nepal's experience implementing an innovative conservation policy. We hope our methods will be useful for future study of community forestry in different contexts and compared to alternate governance structures. If other areas are able to replicate Nepal's success, community forest management could play an even greater role in achieving multiple sustainable development goals." Climate change has worsened global economic inequality. A new Stanford University study shows global warming has increased economic inequality since the 1960s. Temperature changes caused by growing concentrations of greenhouse gases in Earth's atmosphere have enriched cool countries like Norway and Sweden, while dragging down economic growth in warm countries such as India and Nigeria. Our results show that most of the poorest countries on Earth are considerably poorer than they would have been without global warming, said climate scientist Noah Diffenbaugh, lead author of the study published April 22 in the peer-reviewed Proceedings of the National Academy of Sciences. At the same time, the majority of rich countries are richer than they would have been. The study, co-authored with Marshall Burke, a Stanford assistant professor of Earth system science, finds that, from 1961 to 2010, global warming decreased the wealth per person in the world's poorest countries by 17 to 30%. Meanwhile, the gap between the group of nations with the highest and lowest economic output per person is now approximately 25% larger than it would have been without climate change. Although economic inequality between countries has decreased in recent decades, the research suggests the gap would have narrowed faster without global warming. Ideal temperature for economic output. The study builds on previous research in which Burke and co-authors analyzed 50 years of annual temperature and GDP measurements for 165 countries to estimate the effects of temperature fluctuations on economic growth. They demonstrated that growth during warmer than average years has accelerated in cool nations and slowed in warm nations. The historical data clearly show that crops are more productive, people are healthier, and we are more productive at work when temperatures are neither too hot nor too cold, Burke explained. This means that in cold countries, a little bit of warming can help. The opposite is true in places that are already hot. In the current study, Diffenbaugh and Burke combined Burke's previously published estimates with data from more than 20 climate models developed by research centers around the world. Using the climate models to isolate how much each country has already warmed due to human-caused climate change, the researchers were able to determine what each country's economic output might have been had temperatures not warmed. To account for uncertainty, the researchers calculated more than 20,000 versions of what each country's annual economic growth rate could have been without global warming. The estimates in the paper capture the range of outcomes delivered by those thousands of different routes. For most countries, whether global warming has helped or hurt economic growth is pretty certain, said Burke. Tropical countries, in particular, tend to have temperatures far outside the ideal for economic growth. There's essentially no uncertainty that they've been harmed. It's less clear how warming has influenced growth in countries in the middle latitudes, including the United States, China and Japan. For these and other temperate climate nations, the analysis reveals economic impacts of less than 10%. A few of the largest economies are near the perfect temperature for economic output. Global warming hasn't pushed them off the top of the hill, and in many cases, it has pushed them toward it, Burke said. But a large amount of warming in the future will push them further and further from the temperature optimum. Dragged down by warming. While the impacts of temperature may seem small from year to year, they can yield dramatic gains or losses over time. This is like a savings account, where small differences in the interest rate will generate large differences in the account balance over 30 or 50 years, said Diffenbaugh, the Kara J. Foundation professor in Stanford School of Earth, Energy and Environmental Sciences, Stanford Earth. For example, after accumulating decades of small effects from warming, India's economy is now 31% smaller than it would have been in the absence of global warming. At a time when climate policy negotiations often stall over questions of how to equitably divide responsibility for curbing future warming, Diffenbaugh and Burke's analysis offers a new measure of the price many countries have already paid. Our study makes the first accounting of exactly how much each country has been impacted economically by global warming, relative to its historical greenhouse gas contributions, said Diffenbaugh, who is also Kimmelman Family Senior Fellow in the Stanford Woods Institute for the Environment. While the biggest emitters enjoy on average about 10% higher per capita GDP today than they would have in a world without warming, the lowest emitters have been dragged down by about 25%. This is on par with the decline in economic output seen in the U.S. during the Great Depression, Burke said. It's a huge loss compared to where these countries would have been otherwise. The researchers emphasize the importance of increasing sustainable energy access for economic development in poorer countries. The more these countries warm up, the more drag there's going to be on their development, Diffenbaugh said. Historically, rapid economic development has been powered by fossil fuels. Our finding that global warming has exacerbated economic inequality suggests that there is an added economic benefit of energy sources that don't contribute to further warming. Diffenbaugh is also an affiliate of the Precourt Institute for Energy. Burke is a Center Fellow at the Freeman Spogli Institute for International Studies and, by courtesy, at the Woods Institute for the Environment.